Hi girls, we are going to explain today Hess's law. First of all, let's discuss what Hess's law describes. Hess's law describes the enthalpy of a reaction, and he said that the enthalpy of a reaction is independent of the route taken. Let's take an example. If we have a reaction between A plus B to produce C plus D. So A and B are reactants, C and D are products, and you are asked to calculate delta H of this reaction. You don't have any idea about any of those, but you are given heat of formation, standard enthalpy formation of some of those. As per your knowledge, if we have enthalpy of formation of reactants and products, we can calculate the enthalpy of the reaction. So if you are given the standard enthalpy of formation of A and standard enthalpy of formation of B and standard enthalpy of formation of C and standard enthalpy of formation of D, you can calculate delta H by summating the enthalpies of products, the enthalpies of formation of products, and the enthalpies of formation of reactants. So it will be very simple. Okay, so the delta H for this kind of reactions will be sum of standard enthalpies of formation of products minus sum of enthalpies of formation of reactants. Okay, these kind of problems will be very simple to answer. But what if we don't have even sum of enthalpies of formation of reactants and products? So you should get them in an indirect way. And this is what Hess was explaining. Suppose we have a reaction like the previous one, A plus B to give C plus D. Both of them are compounds, all of them are compounds, and each of them has its standard enthalpy of formation. You can A and B, if we reverse the equation, so here, if I have here enthalpy of formation of A, and here enthalpy of formation of B, you can reverse it by changing them into elements. Okay, and the enthalpy here will be minus enthalpy of formation of A and minus enthalpy of formation of B, because when you reverse the reaction, you reverse the sign. Those elements can form C and D. So C and D can be produced from a reaction of the two compounds A and B, and also can be produced from the reaction of the elements that were in A and B to form C and D. Here I have enthalpy of formation of the reaction. According to Hess, delta H shouldn't be different if you go to root 1 or to root 2. So root 1, A plus B gives C plus D. You can calculate delta H as per the previous slide, enthalpy formation of products minus standard enthalpies of formation of reactants. But what we don't have that, you can also calculate delta H from the enthalpies of by reciprocal or the reverse of enthalpies of A and enthalpies of formation of A and B, and here for the second route of reaction. So the second route of reaction has two steps, step 1 and step 2. And the first route of reaction, the reaction happened only in one step. Okay, so root 1 has an enthalpy which equal the root 2. In order to go to root 2, you should calculate the enthalpies of stage 1 plus the enthalpies of stage 2. Let's take an example. Example 1. If C solid form react with 2 water molecules in the gas form to form carbon dioxide in a gas form and 2 hydrogen molecules in a gas form, and you are asked to calculate delta H of this reaction. What was given to us? Given to you enthalpy of formation of carbon dioxide. Standard enthalpy formation of carbon dioxide. Remember, standard enthalpy means in the standard conditions of temperature and pressure. And you are given also the enthalpy of formation of water. But here it seems like you have enthalpy formation of 2 water molecules, 2 moles of water, not only one, for a 3.6 kilojoules. How to solve this problem? Solution. First, you need to rearrange equations so that reactants and products are on the correct side of arrows. And if the equation is reversed, the sign of delta H is also reversed. And then we need to look for the coefficient. Does it need to multiply or divide, or it's correct? After doing all of that, you are going to add the two equations. Let's get started. Here I have started with 1 mole carbon, and here I have 1 mole carbon. Both of them are on the left side of equation, so we don't need to make any change here. So I will consider this equation 1. Second, look for the second equation. Here we have water on the right side as a product, while in the reaction given to us it was on the left side. Here you need to reverse this equation. So first thing you will do, you will reverse the second equation. So it will be 2H2O gas produce 2H2 plus O2. And the delta H, reverse the sign also, it will be positive 483.6 kilojoules. Look at the coefficient. We have here 1 mole and here 1 mole, so no problem here. And in the second equation, we have 2H2O and I have here 2H2O. So I will consider this is my second equation. And then add equations 1 and 2. By adding the two equations, so C plus O2, write all reactants together plus 2H2O gives, now forget about this equation, we are not using it anymore, CO2 gas plus 2H2 plus O2. And for delta H, you need to add the two values. You are going to add those values to calculate the value of delta H. So the delta H here equals 90.1 kilojoules. Okay, we need to cancel out any atoms that are repeated on either side, like here I have O2, will cancel out with the O2, and then write the equation in its final form. CS plus 2H2O gas gives CO2 gas plus 2H2 gas, and delta H equal 90.1 kilojoules. Here we have solved the problem and we calculated the value of delta H by using an indirect route. Sometimes you are asked in that kind of reactions to draw Hess's diagram. Also, Hess's diagram can be used to check out your answer. Remember that the equation that he was asking about, it was C plus H2O to produce CO2 and H2O. This is the value of delta H that we calculated and we found it 90.1 kilojoules. Let's check it. Here, the equation that you are added, first equation was included carbon. First reaction we used, it was carbon plus O2 to produce CO2. So C plus O2 produce CO2. And the delta H here, the heat of formation of this reaction was minus 393.5 kilojoules. Also, we used another equation. Remember, the 2H2O that were used to produce O2 and H2. So we are going to write H2 again here. And the delta H for this part of reaction was 483.6 kilojoules. Now we need to label on our graph where is root 1 and root 2. This is root 1 and here is root 2. So in order, according to Hess, the delta H is independent of the root taken. So if you submit these values, 483.6 kilojoule plus minus 393.5 kilojoules, you will get the value 90.1 kilojoules. Now you can prove that you are working correct. Let's take another example. Calculate delta H for this reaction. 2S plus 3O2 giving 2SO3, and you have heat of formation of some compounds also given to you. You are given the enthalpy of formation of SO2. So SO2 delta H equal minus 297 kilojoule. That's given to you. Also, you are given another equation. 2SO3 produce 2SO2 plus O2 and delta H equal 198 kilojoules. How to solve? Look at the reactant and product to see, do you need to arrange equations or not? We need the products and the reactant to be on the correct side of the arrows. Reactant here, S is correct, plus O2. So I'm not going to reverse equation A. If you look at equation B, I have here SO3 as a product and on this equation as a reactant. So you need to reverse equation 2. Reverse or equation B here, equation B. So 2SO2, you reverse it, make the arrow in the opposite direction, plus O2 gives 2SO3. Delta H will be reversed, minus 198 kilojoules. Second step, you need to look for equation 1. Does it need to be multiplied to obtain the correct coefficient or not? And if you multiply it by a number, the delta H should be multiplied by the same number. So now we need to multiply multiply equation A by 2. Why we should do that? Because here we have 2 moles of sulfur, but the equation given to me 1 mole of sulfur. So you need to balance the equation to have the correct coefficient, you will multiply it by 2. And don't forget to multiply delta H also by 2. Gives 2SO2. Delta H equal minus 297 times 2 equal minus 594 kilojoules. And then you will add equations 1 and 2. The two equations that you did. Let me write them here again. The first equation was 2S plus 2O2 gives 2SO2. And delta H equal minus 9594 kilojoules. Equation 2 was SO2 plus O2 to give 2SO3, and the delta H equal minus 198 kilojoules. By adding both equations, copy them as they are, reactant side, separate them from the product side. So I have here 2S plus 2O2 plus 2SO2 plus O2. If you forget to write the state, marks will be cut from you. 2SO2 plus 2SO3. And the delta H will be minus 594 plus minus 198 equals minus 792 kilojoules. Then what you need to do is to cancel out repetitive molecules if you need to make any addition or subtraction. Here 2SO2 will be cancelled with 2SO2. So I have here 2S plus 2O2 plus 1O2 equals 3O2. 2SO3. And copy the value of delta H. This will be our final equation. Sometimes you are asked to draw a diagram. You will see that in the next slide.